Hey guys, it's your bit of Fukushima news. This was done back in 2022. Concrete melted off pedestal for damaged reactor in Fukushima. Rebars in the pedestal, which are normally covered with concrete, are seen exposed inside the number one reactor at the Fukushima number one reactor power plant. The concrete support foundation for a reactor whose core melted down at the Fukushima number one nuclear power plant has deteriorated so much that the reinforcement bars are now exposed. Governor of Fukushima Prefecture has expressed concerns about the earthquake resistance of the pedestal for the number one reactor at the crippled plant operated by TEPCO. Strong quakes struck off the coast of the prefecture in 2021 and 2022. There have been events that caused anxieties among residents of our prefecture, including damage to the foundation supporting the number one reactor's pressure vessel. A prefectural assembly session in September. We will check up on TEPCO's efforts so the decommissioning work will proceed safely and steadily. The cylindrical pedestal, whose wall is 1.2 meters thick, is 6 meters in diameter. It supports the reactor's 440-ton pressure vessel. The interior of the number one reactor's containment vessel was inspected in May for TEPCO's eventual plans to retrieve the melted nuclear fuel that dropped to the bottom of the vessel during the 2011 nuclear disaster. The study found that the normally concrete encased rebars were bare and the upper parts were covered in sediment that could be nuclear fuel debris. The concrete likely melted off under the high temperature of the debris. The International Research Institute for Nuclear Decommissioning, an entity set up to power utilities and nuclear reactor manufacturers, conducted a simulation in fiscal 2016. IRID said seismic resistance would remain uncompromised even if about 1/4 of the pedestal was damaged. However, only a part of the pedestal was inspected during the May study, and only from the outside. The pedestal's inside remains a mystery. The pedestal soundness is of foremost concern, said Kiyashi. Whatever. A former engineer with the Toshiba Corp, who is now an advisor to the Fukushima Prefecture government on nuclear safety issues. It is important to first inspect the pedestal from the inside. TEPCO has prepared 6 types of robots to detect the fuel debris and perform other tasks in series of inspection at the number one reactor. An internal study of the pedestal is planned toward the March end of fiscal year as the final mission during the inspections. The task carries the risk of robot hitting the sediment or other obstacles and being unable to return. We understand people's concerns very well. We have to understand there's been like 7, 8, 9, 10 robots that have shut down inside the reactors. They got fried from the radiation. We hope to finish studies inside the pedestal by the end of the fiscal year. He said that his company will scrutinize whether the previous assessment of the seismic resistance is still applicable. Keep watching, guys. Keep watching. This person, who has been studying the Fukushima nuclear disaster, called for immediate emergency safety measures such as infusing concrete to reinforce the pedestal. There's a critical defect in terms of quake resistance, based on photos showing the interior of number one reactor. He studied the seismic structural design for the nuclear reactors when he worked on for Mitsubishi Heavy Industries. He also served as the on-site manager for number 3 reactor in that nuclear plant. The photo released following the May inspection shows how concrete covering the cylindrical inner skirt of the pedestal had melted off, laying bare part of the steel frame and rebars from the bottom to the top. The inner skirt's functions connect the reactor's pressure vessel with the containment vessel, but the melting of the concrete has separated the pressure vessel from the containment vessel and weakening the structure's quake resistance. The loss of concrete has also decoupled the pedestal's walls from the floor, making it more prone to sway during seismic events. He said that all concrete around the rebars inside the pedestal has likely melted away. He also said fuel debris that flowed out from an aperture likely melted the concrete around the rebars over about a quarter of the outside circumference of the pedestal. His simulation has shown that the support capability of the pedestal now is about 3/8 of the original level. In such a state, the reactor could topple over in an earthquake of upper 6 on the Japanese seismic intensity scale of 7. He added that repeated exposure to seismic shocks could cause cracks in the remaining concrete, further undermining quake resistance. The very fact there are chances of the reactor toppling is unacceptable, he said. Officials should proceed with safety measures and inspections at the same time. Let's take a closer look at his drawing here. So let's take a closer look here. First, we'll notice the top, work our way down to the bottom, and you'll see what he's talking about, the pedestal that holds the pressure vessel. This middle section right here, that oval shaped section is the pressure vessel. And that concrete, the darkened area, is holding it up. But the fuel melted all the way through that pressure vessel where it was at, down to the pedestal of the containment vessel, and it is melted through the base of that pedestal and has melted through at least a quarter of the entire pedestal down at the bottom. That's just like 1.5 meters thick. We already know in Unit 3, the fuel is down in these wells, down here. No longer inside the containment vessel. And the same is true with 1. If it's down on this pedestal, there's nothing keeping it from leaving the containment vessel and entering the wells down here. At which point it could just keep on going until they cooled it enough to solidify it. Once it, even if it went into the ground, it would hit groundwater, especially being really close to the ocean. The water table has to be extremely high, and that water table would cool that fuel down and solidify it. So no China syndrome. Even if it makes it out of a nuclear reactor, it's not ever going to burrow down really deep into the core of the planet, or the mantle, or the crust, or even the top foot. Once it hits water, it's done. It'll spread radiation, absolutely, but it won't keep melting down. It'll solidify. It'll create a crust around the corium. And it'll cool from the outside in, just like the elephant's foot that isn't in water. It's ambient air cooling from the outside in. So that's what's going on number 1 reactor in Fukushima. Tell me what you guys think. Do you think it would make it through down to the wells? Or would it just stay there, having made it that far? Drop a comment, follow, like, share. I appreciate you guys watching. Keep watching for more. Thanks.